Hello friends, now in this video I will explain the laws of exponent for a real number, all solved examples and exercise 1.6. Now let us start. Laws of exponent for real numbers. That is, do you remember how to simplify the following? See this here, when you want to, the first example is 17 raised to 2 into 17 raised to 5. Now here by the law of indices, both of them have the same base and therefore we can write this as a 17 bracket raised to 2 plus 5 and therefore it is a 17 raised to 7. If the base are equal, then if in between them we have the multiplication sign, then we add the exponent. Then what is the rule? That is a raised to m into a raised to n, that's equals to a raised to m plus n. Okay, now we'll see the next example. 5 raised to 2 and whole bracket raised to 7, that is power to the power, and then we have the multiplication of the power, that is a 5 raised to 2 into 7, and then here you will get 5 raised to 40. Then what is the rule? That is a raised to m and whole bracket raised to n, then here you will have m into n, and that is nothing but a mn. Okay, now the next example, 23 raised to 10 upon 23 raised to 7, again by the law of indices here, 23 raised to 10 minus 7, and that's equals to 23 raised to 3. Therefore, what is the rule here? A raised to m upon a raised to n, and that's equals to a raised to m minus n. This is the rule. Now the next example. Here the base are not equal but the exponents are same. Then we can write this as 7 into 9 and whole bracket raised to 3, and here you get 63 whole bracket raised to 3. Then what is the rule here? That the base are not equal but the exponent are same. Then we can write it as a raised to n into b raised to n in this way. Okay, now the next, that is, to get these answers you would have to have used the following laws of exponent, which you have learned in your earlier classes. Here a, n and m are the natural numbers. Remember that a is the base and m and n are the exponents. The first is, if the base are same and there is a multiplication sign between them, and then we can have the a raised to m into a raised to n is equals to a raised to m plus n. A raised to m and whole bracket raised to n, then the multiplication of their power. Okay, a raised to m upon a raised to n, and that's equals to a raised to m minus n, where m is a greater than n. And if the base are different but the exponent are same, then we can combine them, that is a into b whole bracket raised to m. Now there is one more important thing is also, that is what about the a raised to 0? Any number which is not equals to 0, any non-zero number raised to 0 is 1. Okay, so you have learned that a raised to 0, that's equals to 1. So using this third one, we can get, that is 1 upon a raised to n, that's equals to a raised to minus n. Then how it is? See this here. 1 upon, if I write here a raised to n, then here 1 means what? A raised to 0 upon a raised to n. And again this can be written as a raised to 0 minus n by the law of this division. Okay. What is that rule? A raised to m minus upon a raised to n, and that's equals to a raised to m minus n in this way. Okay, and this equals to a raised to minus n, and therefore whenever we have like this 1 upon a raised to n, and that's equals to a raised to minus n. Okay, now the next is, see this here. For example, 17 raised to 2 into 17 raised to minus 5. Now to solve this, we can write this as, that is a 17 raised to 2. It has a minus sign. Okay, base are the same. Okay, and it is a plus in bracket minus 5. And when this happens, that is a 17 2. This plus minus, that will become minus, and therefore here you will have 17 raised to minus 3. And by using this rule, that is a 1 upon a raised to n, that's equals to a raised to minus n, and also you can write this 1 upon a raised to minus n, that's equals to a raised to this n, and hence we can write this as 1 upon 17 raised to 3. Okay. Now the next example, see this here, again the multiplication of the power to the power, that is 5 raised to 2 into, in bracket, minus 7, and that's equals to 5 raised to minus 14. Here the rule is a raised to m whole bracket raised to n, and that's equals to a raised to m into n. Okay. Now the next example. Again here, this is a very simple example. A raised to, 23 raised to minus 10. Then by the law of indices for the division, minus in bracket 7, and overall you will get 23 minus 10 minus 7, and that's equals to 23 raised to minus 17. Okay. Now the next one, see this here, when the base are not equal and it has the multiplication sign and the exponents are same, then we can write here 7 into 9 bracket raised to minus 3, and this equals to 63 bracket raised to minus 3. Okay. Suppose we want to do the following computation, then how to do it? By using the same rule, that is a 2 raised to 2 by 3 into 2 raised to 1 upon 3. Then again this can be written as 2 raised to 2 by 3, this is the fraction, plus 1 upon 3. Both of them have the same base, we can add it, and that's equals to 2 plus 1. This 2 plus 1, that is 3 upon 3, that is equals to 2. This is one. What about the next? That is the power to the power, then the multiplication of this power, 3 raised to 1 upon 5 into 4, and that's equals to 3 raised to 1 by 5 into 4. 1, their multiplication 1 into 4 is 4 upon 5. Okay. Now the next example, 7 raised to 1 by 5 upon 7 raised to 1 by 3. Again, let's see 7 raised to 1 by 5 minus 7 raised to 1 by 3. And this equals to, now the cross multiplication, using cross multiplication we can solve this. 3 into 1, you will get here 3. 1 into 5, here you will have the 5. And the 5 into 3, 50. Therefore, 7 raised to minus 2 upon 15. Okay. 5 is in the half indices for the division. For the next example, again, both of these two have the same exponent, but the base is different, and therefore we can write here 13 into 17 and whole bracket raised to 1 upon 5. We can multiply these numbers also. 17 into 3, then here you will get 51. 5 will carry. 17 into 1, 17. 17 plus 5, you will get here 22. And whole bracket is to 1 upon 5. Okay. Now the next. In the language of exponent, we define nth root of a, and that's equals to a raised to 1 upon n. So in particular, that is a cube root of 2, and that's equals to 2 raised to 1 upon 3. Now there are now two ways to look at 4 raised to 3 by 2. Now this 4 raised to 3 by 2 can be written as 4 raised to, that is, we can write this as 4 raised to 1 upon 2 and whole bracket raised to 3. Okay. And therefore, first 4 raised to 1 upon 2 bracket raised to 3. But 4 raised to 1 upon 2 means of square root of 4. That is equals to 2. 2 raised to 3. And here is a 8. Okay. If first we are taking here the denominator, that is a 4 raised to 1 upon 2. And suppose that if we write 4 raised to 3 by 2, it's like this. If 4 raised to 3 and whole raised to 1 upon 2. But what is a 4 raised to 3? It is a 64. And the square root of 64 is again 8. Okay. Now in this way, 4 raised to, that is a, I can write here 4 raised to 3 by 2 can be written as 4 raised to 1 upon 2 whole bracket raised to 3, and next is a 4 raised to 3 bracket raised to 1 upon 2, and overall that's equals to 8. Okay. Therefore, we have the following definition. A is a positive and it's a greater than 0, be a real number. Let m and n be the integers such that m and n have no common factors other than 1. And n is positive, n is a greater than 0. Then a raised to m upon n, that's equals to nth root of m bracket raised to m, or again it can be also written as nth root of a raised to m in this way. We now have the following extended laws of exponent, okay, for the rational. That is a is a positive, a is greater than 0, be a real number, and p and q be the rational numbers. Then we will have a raised to p into a raised to q, that's equals to a raised to p plus q. A raised to p and whole bracket raised to q, that is the power to the power, their multiplication of the power. Same rules are there. Only fact is that instead of m and n, we are taking here p and q, which are the rational. A raised to p upon a raised to q, and that's equals to a raised to p minus q. Next, if the base are different, powers are same, then we can also combine them. That is ab whole bracket raised to p. You can now use these laws to answer the questions asked earlier. Now see this here, 2 raised to 2 by 3 into 2 raised to 1 by 3. Okay, the base is same. Okay, and there is a sign between them is a multiplication. Then we can add these powers, that is the 2 raised to 2 by 3 plus 1 by 3. 3 by 3, the 2 raised to 1, and that is the 2. Now the next is a 3 raised to 1 by 5 whole bracket raised to 4. Again, it can be written as the multiplication of the power 1 by 5 into 4. Okay, it's very simple. 1 by 5 into 4, and that's equals to 4 upon 5. Okay, now the next is a 7 raised to 1 by 5 upon 7 raised to 1 by 3. The division a raised to m upon a raised to n. Then you will get a raised to 1 by 5 minus 1 by 3 cross multiplication, and here you will get 7 raised to minus 2 upon 15. Now the next is 13 raised to 1 by 5 into 17 raised to 1 by 5. The base are different, but the exponent is same. Therefore, 13 into 17 whole bracket raised to 1 by 5. Their multiplication is a 221 bracket raised to 1 by 5. Okay. Now we'll start the exercise 1.6. Now this is very simple example. Find the value of 64 raised to 1 upon 2. Now this 64 can be written as 8 raised to 2. Okay. And here we have the 1 upon 2. And that is 8 raised to power to the power means multiplication of the power. 2 into 1 upon 2. And here these 2 get cancelled. 8 raised to 1, and the answer is 8. Okay. Next example. 32 raised to 1 by 5. 32 is the fifth power of 2. Therefore, I can write here 2 raised to 5 and whole bracket raised to 1 upon 5. And therefore, here 2 raised to 5 into 1 upon 5. Again, this 5 get cancelled, multiplication. And here you will get 2 raised to 1, and that is 2. Okay. Next is a cubic root of 125. Again, we can solve it like this. 125 means what? 5 raised to 3. And whole bracket raised to 1 upon 3. Multiplication of their power. That is a 3 into 1 upon 3. Here you will get 5. Okay. Now the next example. Find the value of 9 raised to 3 by 2. It's very simple. 9 means what? 3 raised to 2. And whole bracket raised to 3 by 2. And here you will get 3 raised to 2 into 3 by 2. This 2 will get cancelled. And here you will get 3 raised to 3. And that is equals to 27. Okay. Next example. 32 raised to 2 by 5. Again, this 5 is very important. The 32 is a 2 raised to 5. Therefore, we can write here 2 raised to 5 and whole bracket raised to 2 upon 5, and that's equals to 2 raised to 5 into 2 by 5. This 5 get cancelled, and here you will get 2 raised to 2, and that's equals to 4. 4 is the answer. Okay. Next, 16 raised to 3 by 4. Now 16 means what? 2 raised to 4. Answer is here 2 raised to 4. Therefore 2 raised to 4 and whole bracket raised to 3 by 4, and that's equals to 2 raised to 4 into 3 by 4. This 4 get cancelled, and here you will get 2 raised to 3, and that's equals to 8. Okay. Now the next example. 125 raised to minus 1 by 3, but 125 means what? 5 raised to 3 whole bracket is to minus 1 by 3, and here you will get 5 raised to 3 into bracket minus 1 by 3. Here this 3 will get cancelled, and here you will get 5 raised to minus 1. Again, it can be written as that is a 5 raised to 1, and overall here you will get 1 upon 5. Okay. Next, we want to simplify this. Again, the base are same, and in between them there is a multiplication sign. Therefore, by using the law of indices for the multiplication, that is a 2 raised to 2 by 3 plus 1 upon 5, and that's equals to cross multiplication. 5 into 2, you will get here 10. 1 into 3 plus 3 is whole divided by 15. That is a 2 raised to 13 upon 50. Okay. Next example. 1 upon 3 raised to 3 and whole bracket raised to 7. Again the power to the power multiplication. Here you will get 1 by 3. Okay. 1 by 3, and this is the bracket, that is raised to, first of all here 3 bracket raised to 7, and therefore here you will get 1 upon 3 raised to 3 into 7, and that's equals to 1 upon 3 raised to 21. Here I will write again 1 upon 3 raised to 21. You can solve this also like this. 1 upon 3 means what? Here is 3 raised to minus 3 bracket raised to 7. Again power to the power multiplication of the power, that is 3 into 7. Here you will get 3 raised to minus 21. Again this minus exponent can be written as plus, that is 3 raised to 21 in this way. Now the next example, division. Okay, 11 raised to 1 upon 2. Base are same, and sign between them is a division. Therefore, we will subtract it. 1 by 4. Here 11. 1 upon 2 minus 1 by 4. Now the cross multiplication. That is 1 upon 2 minus 1 by 4. Overall, it will be the 1 by 4. Now see this again. Cross multiplication. 4 into 1. Here you will get 4 minus 2. And the multiplication of these 2 and 4, 8. Here 11 raised to 2 upon 8. 11 raised to 1 by 4. And therefore, here you will get 11 raised to 1 by 4. Answer. Now the next is the base are different. Sign between them is a multiplication. Therefore, we have the multiplication of their power. That is 7 into 8 whole bracket raised to, base are same. The multiplication of their base we can write here 7 into 8, 56, and bracket raised to 1 upon 2. Okay, and in this way we have completed this exercise 1.6. Now we'll see in the next video. Till then, goodbye.